Before we start the session, any queries, questions, or doubts that you'd like to ask me before we begin? Yeah. All right. So if there are no questions or doubts, let's get started off with the session itself. Yes, otherwise I'll switch off my video. If you all don't switch on yours, then I'll switch off mine. Okay. All right. We had stopped yesterday halfway through talking about inheritance-based examples. So a couple of things that we had done out there, we had just seen how to inherit from one class. That's the first thing that we had seen. And then the second thing that we had tried out was access specifiers. So I'm going to actually open the same project as yesterday and start off with that. Yeah, so just checking what we had done last. Let me go on for a new project because I think I'm saving it as day 1, day 2, day 3. So let's save it that way. So I'm going to copy paste some code and get that working or get that out here. But while I'm copy pasting that, let me talk about what that code is supposed to do, and then you all can help me with that. So what I'm going to try out next is, what if there were constructors in your base class and your derived class? Then how does this work? How does it function? Right? And in the example that I have a constructor in the base class and in the derived class as well. And I'm going to ask you simple questions. I'm going to ask you what would happen when you go ahead and create these. So 1 second. And I'd like you to give out the output in the chat window. So whatever while I'm copying, just give me a minute more while I copy that. So I'd like you all to give me the output of what you think will happen in the chat window. Okay, so finally I've got the code. And let me show you what I have out here. So I have a base class which has this code out here. Right? So look at the code for the base class. I have one member in the base class. निशा मैम क्या किया जाए, एडमिट किया जाए या डिसअलाउ किया जाए, people are coming in late. Nisha ma'am, what is your opinion? Should we allow them? Should we not allow them? People who walk in late. I'm not sure that Nisha is here or not. Okay. All right. So don't walk in late. I feel bad if I'm 10 seconds late also. Don't walk in late. I would not want you to miss the session. I will not allow you all in next time now. Coming back to this problem, we have one variable I in the base class, and I have a derived class that inherits from the base class. I also have an additional variable j. So what are the members in the derived class right now? What would I have in the derived class? Yes. What will be the member?
I and J.
Right? Yeah. So I have now a constructor in the derived class, which is a no parameter constructor, and a constructor in the derived class, which is a 2-parameter constructor. So this is what I have out here. This is the structure of my class. I'm initializing values to 10 and 20. I'm initializing values to, whatever the values that I have received out here. Okay. So have we understood the structure of what this whole thing is all about? And here is where I'm going to ask you the questions. Okay. So if you notice that there are 4 constructors, I mean 2 in the base, 2 in the derived. And my question to you is going to be which constructor will be called when? Okay, so wait for me to ask the question. Don't call out the answer. What if I create an object of the derived class? So again, I'm doing this, creating an object of the derived class, not passing any parameter there. And this is my code in the base class. This is my code in the derived class. My first question to you is, which constructors will get called, and if more than one is going to get called, in what order are they going to get called? So what will be the output that will be shown to you here? When I run this code, what will be the output? So remember the output statements that are there here. Okay, these are the output statements. So if I create an object of the derived class, all I'm asking you to do is type out in the chat window, what do you think the output would be? Go ahead, answer in the chat window, please. I would like all of you all to answer. Okay, now somebody just said base class constructor then derived class, but there are 2 constructors in the base and 2 in the derived. So which one in the base, which one in the derived? If somebody is saying derived class constructor only, then which constructor of the derived? That also you have to answer.
Yes, sir. I'm admitting the students now.
Yeah. Nisha ma'am, but we...
Yeah, sir. I have done that part of absentees and all those things.
No,
yes.
not just absentees. Next time I will not allow them. So,
yes, sir. Noting down. Yeah.
So you need to maybe just give them a warning in terms of the sir is
Right.
he really doesn't allow the people.
Yes, sir. Yeah.
What do you mean by default class, Vaibhav? There's no default class. There's either a base class or a derived class. Okay, 10 seconds more to complete your replies. Right, 10 seconds more. All right. So majority of you all have given the answer correctly, that when you run this line of code, both the constructors get called, and the order of seeing the output is first the base class constructor will finish executing, and secondly the derived class constructor will finish executing. For both of these, the no parameter constructor will be called. Let's confirm this. Let's run this code and confirm this. When I run this code, right? So you have the base class no param constructor followed by the derived class no param constructor getting called. Now, if you look at the order in which this code executes, let's put it in breakpoint and see what is happening out here. All right. So when I run this code, all right, and let's see what happens next. Now, at this point, the next line of code that is checked, it does not go into the base class constructor directly. It does not first go to the base class constructor. You saw that the output was that the base class constructor was directly called. But that is not how exactly it works. So what happens next is from this point, it actually goes to the derived class constructor. And which constructor of the derived class is it going to go to? In this case, the no param one, because you haven't passed any parameters. So it goes to the derived class no param constructor. But it does not execute this constructor. It does not finish executing this. So why does it come here? What is the reason for the statement to come here?
There is a so-called keyword.
It comes here to check which constructor of the base should be called. Now, at this point, I have not instructed it anything. I have not told it which constructor to call. So by default, it will go and call the no parameter constructor of the base class. Right? So from this point, it does not execute the derived class code. It does not do this code instead. Instead, what does it do? It goes to the base class constructor, which does not have any parameters. Why does it go there? Why does it go there?
Super keyword internally.
Because we have not told it, we have not instructed it which constructor of the base to call. So by default, what is it doing? By default, what is it doing? Calling
Parameter class constructor.
The no param constructor. Now in the no param constructor, what does it do here? It initializes the base class members. So of course, that console.writeLine happens, but more than that, it is initializing that I to 10. So the base class member has got initialized out here. Okay. Now, if the base class member has got initialized here, then do I need to reinitialize it in the derived class? The base class member I has got initialized here to its value of 10. So do I need to initialize it again in the derived class? Is my question. No need, right? No need to do that. So the base class members have been initialized in the base class constructor. And then it finishes the base class constructor and comes back to the derived class. Now, what should the derived class do here? What should it do out here? Of course, there's a console.writeLine for you to see what's happening. But what should it do here now? It should only initialize. It should only initialize what?
J.
J. So what is J? The derived class members. This line is not needed since it's already being done in the base class. I is equal to 10 is not needed. So what would I need to do here in this case? Only J is equal to 20. And I can remove the I is equal to 10. Right? That I is equal to 10 is a duplication of code. I don't need that. And this is how this code worked. So this gave you the base class no param constructor followed by the derived class no param constructor. Come back here and remove this code since this is happening in the base class. So far, so good. Everybody is giving me the right answers. You all know your concepts well. All right, let me comment out this, and I'm going to ask you this question again. So hold on before I ask you the question. Now, in this case, what am I doing? I'm calling the derived class constructor, which takes parameters. Okay. Again, the question is going to be the same to you all. What is the output going to be in this case? Which constructor from the base and which constructor from the derived would be called? Go ahead and please answer that in the chat window. This is the line of code that I have written down. Okay, this is the line of code that I have written down, and these are the constructors that I have. Saurabh, only one will be called. Mohit, is that the order in which it is called? You have to maintain the order.
No, sir, it is not in order. Like,
so you have to give it to me in order, no?
Okay, sir. Okay, sir.
Somebody didn't mention which the name scrolled by, but you didn't tell me which constructor of the derived is being called. You just said derived. All right. 10 seconds to complete this output. All right. Please stop and coming back to the explanation. So excellent. Majority of you all know your concepts very well. Well done. So the correct answer is the base class constructor without parameters and the derived class constructor with parameters. Let's confirm that. Let's put into break mode and run this code. So from here, it's obviously going to jump to where? Where will it first jump to?
Derived class.
Derived class constructor with 2 parameters.
Yes.
Right? Perfect. Here, have we again told it which constructor of the base to call? In this case, again, we have not told it which one to call. So by default, it will go and call the base class constructor without parameters. Now, if you notice, I have received values here for ing. What are the values that I have received? 1, 2, 3, and 4, 5, 6. So these values that I have received here, 1, 2, 3, and 4, 5, 6 need to be initialized in this.i and this.j. So let's continue here. But what is the base class constructor initializing it to? What is it currently initializing it to? It's initializing it to 10. What do we want to initialize it to? 123. So there is another constructor here which is actually receiving a parameter and initializing it to that. So first thing is we don't want to call this constructor, but we like to call this constructor instead and pass it a value. So if we can pass it a value, then we don't need to do this code. We'll be able to run this code, which will initialize it to the correct value. So that's the first thing that I'm going to do. I'm going to show you how to call the base class constructor with a parameter instead of the no param constructor. All right. The second thing, of course, here is since it's going to be done in the base class, therefore this line can be removed wherein I'm initializing it in the derived class. I can totally remove this line, and the derived class should only have what? initialization code for its new members, in this case J. So these are the changes that I'm going to make. First thing is, of course, remove this change, remove this line. And secondly, call the base class constructor with parameters. Now the keyword that you use here in C# is base. So the base keyword refers to your base class. And if you look at this, this is actually having you, showing you two constructors, right? So it's showing you one without parameters and the one with parameters. So the value that I receive here, I'm actually passing that to my base class. Right? Okay, so this would ensure now that the constructor that would be called would be the base class constructor. Let's try running this code. Again, in a breakpoint. So once here, the value of I has been received here as 123. That value has been passed to the base class. And the base class then initializes its members. And then finally, the derived class comes and initializes the extra members in the derived class. So this is a concept that you all knew well. Well done. You all remember the concept from what you all have done in Java. Right? Okay. Moral of the story is what? The base class members should be passed to the base class, and the derived class members should be initialized in the derived class. The derived class should not be initializing the base class members because the code has been already written in the base class. So that is what you have to ensure. And to do that, you can call a specific constructor of the base class which accepts the values. Right? All right. Now I'll take you back to yesterday's assignment. Somebody's mic is on. If you can turn that off. I can take you back to yesterday's assignment. In yesterday's assignment, you had to write multiple constructors. So you had, like in the first assignment, you had 4 parameters. So you needed to have a constructor which took, somebody's mic is on. So just turn that off. So if you had a constructor with, if you had a class which had, 4 members, you need to have a constructor which takes 4 parameters, 3 parameters, 2 parameters, 1 parameter, and 0 parameters. So some of you all showed me the code yesterday, right? And you all actually wrote multiple constructors. Now, although that approach is not wrong, that is a duplication of effort. What is the better way of doing this? What would be a better way of doing this?
Default parameter constructor.
Correct. So write one constructor which takes default parameters. Furthermore, the values that you're giving in the default parameters should not be contradicting the code that you have written in your properties. So in your properties, for example, if you're written code which says that the employee number should be greater than 0, but if you're giving a default value of 0, that defeats the purpose. So the default value that you give should be valid values according to the code that you're written in the properties. So that was the second mistake that some of you were making. Are you all getting what I'm trying to say? Supposing
Yes,
you have given a default value of, let's say your basic has a validation of, it should be between 10,000 and 50,000. But the default value you give it as 0. So that means what are you doing? You yourself are giving a wrong value. So that is the point I'm making. So this was the small mistake that I noticed in people who showed me the code yesterday. Not everybody, of course, but some people had that problem. Second problem was what people wrote multiple constructors. So do not write multiple constructors. Write one constructor that will take care of it. If you're having inheritance out here, if you're having inheritance mechanism, what should the derived class do? Firstly, there'll be only one. I have purposely put in two constructors to show you how the constructors are getting called. But ideally, you would be doing this with only one constructor. And what should the derived class always be doing? Pass the values to its base class. So base class takes care of initializing its members. And derived class then initializes the additional members that have been defined in the derived class. So please remember to do this. All right. There's an assignment coming your way later again today, which will test you on this concept. Okay. So please try and remember these basic things. You all have all answered very well. So you all know the funda, but you have to practice it when you write down the code. It's not just enough to know the funda. It's important that you implement it when you're writing down code out there. All right. Any questions, any doubts before we move on to the next example?
Sir, if we are creating a class and we are not giving any constructor, so there will be a default, no param constructor.
Correct. Correct.
But if we are giving one constructor with parameter, so there will be any no param constructor in that case?
No.
So sir, how this no param constructor is getting called in this inheritance?
If I'll kick you back to this, what if I had commented out this code? What if I have commented out this code and I have now given what? Only one constructor which takes a parameter. So
Yes,
see
sir.
what happens now. Why is this code giving an error?
Because sir, we have deleted that no param constructor.
And what is this trying to do? What is line number 39 trying to do?
It's calling base
So
class
it's giving an error. So
constructor
that is
also.
does that answer your question?
So it means we need to explicitly give that. If we
Yes.
are commenting out this constructor also line number 39. So what will happen in that case? It will not give error in that case.
You're answering your own questions.
Yeah, that's what I am saying.
Yeah.
So
You're answering your questions. This thing. So if you remove the entire code that is giving you errors, then obviously there's going to be no problem.
so my question is, if I'm giving only parameterized constructor here.
Yes. So no parameter constructor does not get created. Correct. Now what?
Okay, yes, that's what I want to know.
Yeah.
Yes.
That's what we mentioned yesterday itself, right? Yesterday when I showed you the IELTS, we did talk about that.
Yes, sir.
That-
Actually,
yeah.
I was a little bit confused.
Yeah, no problem. So if you had deleted both these lines, both these constructors, then this code would not work. Right? If you removed those constructors, then you will not be able to do line number 16. Okay. All right. So anyway, let's take it further. Any further questions before I go ahead? All right. So let's take another concept. Let's say you had this class employee that you created yesterday, and one of the methods that you had there was calculate net salary, right? Or get net salary. I don't remember what are the name of the method that you created. Either calculate or get net salary. Now, yeah, whatever. Let's say get net salary. Doesn't matter. Okay. Get net salary. Now, what if you created a class called manager that inherits from employee? Right? Now, in this case, the get net salary that has been defined in employee is also available to the manager class. Correct? Now, so far, so good. So the methods that you have defined in the base class are also available to your derived class. Now the question might come up, what if the derived class does not want that implementation of the base class method? What if the base class method has been given in a certain way and the derived class does not like that implementation? Let's say, for example, the calculation of the net salary for a manager is different from all other employees. Now, what do you do in this case? In such a situation, the manager class can provide its own implementation of that method. So the manager class can provide a different implementation of this method, right? And it can write its own get net salary method. Now, while doing so, it can do so in one of three ways. The manager class can write this method, which has been there in the base class. It can write it in one of three ways. So what are the three possible options that you can have out here? The first possibility is that the derived class can overload the method and overload the base class method, right? When you're talking about overloading the base class method, what are you talking about? When you're talking about overloading, what does this imply?
Same name with different
Name
parameter.
same but parameter different.
Right? So the same name, but different parameters. You create in the derived class, you write a method which has the same name, but different parameters. Now, if you do this, and if you try creating an object of the derived class, if you create an object of the derived class and you did O dot, you will find that both methods are available. So base class method is available as well as O dot derived class method is available. So both methods are now available here. So what is happening here in this case? Yes, both methods are available from a derived class object. All right. What have we done out here? We have overloaded the base class method. Right. So this is one possibility. Now the end result here is now you get both methods. You get the base class method and the derived class method. But what if you don't want the base class method to be available? What if the derived class is, you know what, I don't want the base class method to be seen at all. I don't want it to be available here. Now, in such a case, there are two further possibilities that you can do out. There are two possibilities that you can do. The first possibility is the derived class method. The derived class can hide the base class method. What can we do out here? The derived class can hide the base class method. Now, to hide the base class method, the derived class will write a method which has the same name and the same parameters as the base class. Right? What will the derived class do in this case? It will write a method which has the same name and same parameters. Now, when you do this and you try to create an object of the derived class, the only method available to you would be now what? Would be only the derived class method. The base class method will not be available. In other words, what have we done out here? We have hidden the base class method. Are we clear on this, everybody? So what would be available from a derived class object? what method would be available from a derived class object?
Derived class method.
Both.
No,
Directly with
Raji.
derived.
Hidden
Derived
form.
class.
No,
This
sweetheart.
class.
Only the derived class method is available from a derived class object. You will not get the base class method. What have we done? What are we trying to do? The term itself, what are we trying to do? We are trying to hide the base class method. Are we clear on this, everybody? So this is called as hiding the base class method. Clear on this?
Yes, sir.
We said that there are total of 3 possibilities. And when you don't want the base class method to be available, there are 2 things that you can do. So what is the third possibility here? Instead of hiding the base class method, the derived class can override the base class method. That is the third possibility. So instead of hiding it, it can also override it. Now, there are some similarities between hiding and overriding, but there is a major difference between the two. So first, let's talk about the similarities between what happens between hiding and overriding. In both hiding and overriding, in both of them, in the derived class, you will write a method having the same name and same parameters. In both of them, in hiding also, in overriding also. In both of them, when you create an object of the derived class, in both of them, when you create an object of the derived class, only the derived class method is available. Are we clear on this? So far, if you have seen whatever we have talked about so far, hiding and overriding seem identical. They look identical. Correct? Yes. There's no difference right now between hiding and overriding. So these are the similarities. But there is one big major difference between hiding and overriding. Any method can be hidden. Okay, so this is the difference. What are we saying? Any method can be hidden, but only a virtual method can be overridden. All right. So what can you override? Only a virtual method. Are we clear on this, everybody? So first thing is, what is the difference between a virtual method and a non-virtual method? What do you understand as the difference between a virtual method and a non-virtual method? Yes. Is anyone?
So is virtual a keyword that we can give in base class so that only those methods can be overridden?
Yes.
So I think that was the answer. As in base class, we can write virtual keyword against
No,
the.
but my question is, what is a virtual method? You're telling me, okay, we'll give the virtual keyword. It is like saying, what is the difference between virtual and non-virtual? It's like saying the spelling is VIRTUAL. And non-virtual, we will not give VIRTUAL. So That is not a difference. No? I'm asking you what is the basic difference between a virtual method and a non-virtual method. You telling me, oh, we'll use this keyword. That is not a difference.
Okay, sir.
A virtual method can be overridden and a non-virtual method cannot be overridden.
Okay, but what is so special about a virtual method? How is it different? How is a virtual method different from a non-virtual method? What is the basic difference? While you run your code or whatever, what are the differences between virtual and non-virtual methods? You all would have learned this in C++.
Virtual method has no body.
You're talking about a pure virtual function. What answer you gave me would be correct. I'm going to ask you, a little while later, what is a pure virtual function? So remember the answer that you gave me there now.
Yes.
Virtual method should be overridden, sir.
Again, that you're telling me is a pure virtual function. Should be that means must be. That is a pure virtual function. All right. So
Implementation is incomplete.
sorry.
The method is implementation is incomplete.
You're again talking about a pure virtual function. So all pure virtual functions are virtual, but that is not the answer to what is a virtual function. How is a virtual function different from this? Okay, so what is the basic difference between a virtual and a non-virtual function is how are they bound? What is the binding mechanism? All right. All virtual methods are late bound methods. All virtual methods are late bound methods. Another word for late bound is runtime binding. Right? Another word that you might have again used is runtime polymorphism. So what do I mean by late binding, and how is it different from early binding? In late binding, the method to call is not decided when you compile your code. Instead, it is decided at runtime, at execution time, which method should be called based on which object has been created. So late bound code has the flexibility of calling different code because it is being decided at runtime. On the other hand, early bound code, or also called as compile time binding. In early bound code, the function to call is decided when you compile your code. So at the time of compilation itself, it knows what method to go and call. On the other hand, in late bound code, the method to call is not decided initially, but is decided based on what memory is allocated. Now, what this gives me is the flexibility of declaring a reference of the base class type. I can declare a reference of the base class type, but allocate memory for either the base class object or for any of its derived class objects. So what am I allowed to do in late binding? With late binding, what can I do? Declare a reference of type base class. So I would say base class O, but allocation of memory need not be of the base class object. It can be of a derived class object as well. So I could say O is equal to either new base class, or I could say O is equal to new derived class. And a virtual method will look at what type of memory has been allocated and accordingly go and call the correct version of the function, either the base class function or the derived class function. So therefore, it is called as late binding. At runtime, it executes this. Early binding, on the other hand, what happens? At the time of writing the code only, depending upon how you have declared the reference. Supposing I said base class O, and if it is not a virtual function, the code to call, the function to call will be decided at compile time itself, based on how you have declared the object reference. So these are the basic differences between virtual methods and non-virtual methods. Are we clear on this, everybody? And yes, like someone said, the keyword to declare a virtual method is virtual. Right? So full marks for that answer. What is the keyword? The keyword is virtual. Well done. Right? How do you declare a non-virtual function? You don't have a keyword. All functions that you declare by default are non-virtual. To make it virtual, you need to give the virtual keyword. Are we clear on this, everybody? All right. So, taking a quick recap of what we just said. We started off our discussion by saying what? That there is a base class which has some code, and the derived class does not like that code and wants to give in a different implementation of that code. There are three ways in which the derived class can do so. First possibility, it can overload the base class method. When it overloads the base class method, both methods are available from an object of the derived class. Right? Of course, overloading means what? You have the same function name with a different set of parameters. So this is the first possibility. Second possibility is what? Instead of overloading the base class method, it can do what? It can hide the base class method. When you hide the base class method, you give the same function name and the same parameters in the derived class. On hiding a method, only the derived class method will be available from the derived class object. And we furthermore said that any method declared in the base class can be hidden by the derived class. Any method can be hidden. The third possibility that we talked about was overriding the base class method. Overriding is similar to hiding in the sense that you give the same name, same parameters. When you create an object of the derived class, only the derived class method is available. So in that aspect, it is same. But there is one major difference. And the difference is that any method can be hidden, but only a virtual method can be overridden. And what is a virtual method? A virtual method is a method that supports late binding. So this is what we just spoke about in the last few minutes. Any questions, any doubts about any of this before we jump into the code? Because now we'll just try out the code which sort of illustrates these concepts. Any queries before we do that?
So can you please explain virtual method one more time?
Okay. Okay. What if I do this? Let me show you the code. And while showing you the code, I'll explain virtual methods. Okay. Because you can then see the difference. So I'll do an explanation again, but let me get in the code to show it to you so that you can clearly see what are the difference between a virtual and a non-virtual method. All right. All right. Okay, so let's go in the order in which we have done it. We'll first try all of these one by one. I'm going to split up my example into two parts. So in the first part of my example, I will show you overloading, I will show you hiding, and I will show you overriding. I'll show you all these three, but I will not show you the difference between hiding and overriding. I will not show you the difference. I'll show you the sameness. And then in a separate example, I'll show you where they are different. Okay. So let's go ahead and try this out. I am going to copy paste some code to help me save on a little bit of time. Right. I hope you can see what I'm doing. Can you see what I'm doing?
No,
No,
sir.
sir.
No,
Okay,
sir.
good. Good. That's what I want. Okay. All right. I don't want to show you the finished code. I want to show you the code as we go along. All right. Now, I could have probably just typed out the code and it would have been faster. Okay. By doing a copy paste, I don't think I've saved any time. I would have probably typed this code a little faster than what we are doing out here. All right. So I'm ready to run this. Take a look at this. I have a base class in which I have written a method called display1. Right? And that's just the console.writeLine, doesn't do anything out here. The derived class inherits from the base class. The first concept that we are trying is overloading the method. So to overload the method, all that I need to do is what? What am I simply doing? Yes.
Giving parameters.
Increased parameter.
Right. So given the same method name, but a different set of parameters. Now, what would happen when I create an object of the derived class? What will happen when I create an object of the derived class? What will be available? Which method will be available?
So both of them.
Both.
Both of them.
Yeah. Let's try doing this. I create an object of the derived class and I did O dot. When I'm calling display, you'll find that there's an overload here. What is the first one that's available? First method that's available is what? Base display.
Base class.
And second one that is available is what? Derived display. So both are available right now. Let's try calling both. O dot display one, which takes a parameter. This is the derived class. All right. Let's try running this code and you'll find that both of these are available to you. Right. So base display as well as derived display. What did we do right now so far? We have, let me put this comment out here. Okay, that's the first possibility. All right, let's try the second one. Second one, what did we do? Second one, what are we doing? We are hiding. Right? In hiding, what did we say we should do? Hiding, what did we say we should do?
Same parameter.
Same names and same parameters.
Same name, same parameters. Right? So what are we doing here in this case? We are hiding the method in the derived class. Right? Okay. So when I come back here and I, instead of calling display one, if I try calling display two, if I call display two, see what is happening here. Which display is being shown?
Display 2.
Yeah, but
Derived
which
class. Derived class.
derived class?
Derived class.
So there's no way in which I can call the base class display. So what has happened here now? The base class member is hidden,
Hidden to us.
right? Okay. Let's try calling this. And when you run this now, this would actually call the derived class display. So what have we successfully done out here? We are hiding the base class member. Clear on this, everybody?
Yes.
All right. I just need to attend to something for a minute. I'll join you back in a minute. I'm not done. I'm taking a 1 minute break. Don't go away. Yeah, sorry, I was called for an emergency. So what we have here is we have tried out hiding. Now, when we do hiding, all right, when we do hiding, this is done what we wanted it to do. But if you look out here in the derived class, it gives you a warning. All right, it's not an error, it's a warning. So let's read what the warning says.
Hello, sir.
Yes.
Sir, in the line number 87, it should be hiding the method in the base class now.
Hiding the base class method in the derived class.
Okay.
Okay.
Hmm.
So we are hiding the base class method, but we are doing it in the derived class.
Yes, sir.
Okay. So let's look at the warning that it shows me. It says derived class dot display 2 hides the inherited member base class dot display 2. It's hiding it. Okay. Use the new keyword if hiding was intended. Now what it's trying to tell you is that you have given a method name the same as the base class method, and by doing so you are actually hiding the base class method. Now are you sure you want to do that? This is what the compiler is telling you. Are you sure you want to hide it? Because you are giving a same name, same signature. Now the base class method is not going to be called. So is this what you intend to do? This is what the compiler is warning. Now, it also suggests that use the new keyword if hiding was intended. Now, I can go and give this new keyword here. So I can say public new void display 2. And by giving the new keyword, the warning goes away. But this adding this new keyword does not change the way in which my code runs. It has no effect on the way in which my code runs. So my code still behaves the same way as it did earlier without new. Are we getting this, everybody? So what is the difference if I run it again now? What is the difference in the code? There's no difference. The way in which it worked earlier, it's working the same way. What is the only thing that you have achieved here by having the new keyword? What is the only difference?
Elimination of warning.
Correct. The compiler no longer gives a warning. So whether you give new or you don't give new, you are anyway hiding it. You are anyway hiding it. Without giving new, compiler gives you a warning. By giving new, there is no warning. That's the only difference. Are we clear on this, everybody? All right. So we have tried out hiding the method. Third thing, what are we going to try out here is overriding it. But what is the prerequisite here? What is the prerequisite here? Is only a virtual method can be overridden. So let's come back here and let's create a display 3. But mark this as a virtual method with the keyword virtual, spelling virtual. Okay, so that's how you created a virtual method, right? And now we want to override this method. So to override the method in the derived class, you need to give the override keyword. You need to give the override keyword. Now see what happens when I give the override keyword. I'm saying public override, and as I'm typing it out, see what happens when I give a space here. What do you think it's prompting me with? What are these?
Overriding base class display 3 method.
Parent class method.
Parent.
Class method.
So is it showing me all the parent class methods?
Yes, sir.
Yes.
No,
No, sir.
it's not
No,
all the
only
parent. It's not showing me
virtual.
display 1, display 2.
Only virtuals.
Correct. It
From
is
object
only
class
showing
and
me the virtual methods from the base class. So display 3 was a virtual method, and the others equals get hash code and toString. These are also methods that have been defined in the object class, which are virtual methods. Are we clear on this, everybody?
Yes, sir.
All right. So let me come down to display 3, and it generates some code. It's saying go and call base display 3. That's the default implementation. We don't want to do that. What do we want to do out here? We want to put in our own code. So derive display 3. So what are the prerequisite here? Base class, you need to give the keyword as virtual, and in the derived class, you need to give the override keyword. Okay. What are we doing here? What are we doing here?
Hiding base method enter.
Hiding the
Darling, not hiding.
Override.
Override.
Overriding.
Right? Overriding the base class method in the derived class. Okay. All right. Now, when you come back to this, and if you did O dot display 3, which method would be available to you? Which is the only method available to you? Is the derived class method. So in that sense, it's very similar to what we did with hiding. So it's very, very similar. At this point, it looks similar, but we will illustrate the difference also. So let's try running this. And you got your derived class display 3. Questions, if any, at this point? All right. What if the method was not virtual? What if the method was not virtual? And you come down here to the derived class. What is happening now? What is it saying?
We are not getting base class virtual method.
If it is not virtual, you cannot give override. As
Yes.
simple as that. Right? You cannot give that. So it says cannot override that because it is not marked as virtual. So I'll keep it back to virtual. What if I don't give the override keyword? What if I don't give the override keyword? Then what do you think is happening now?
Hiding.
Hiding.
Very good answer. Excellent answer. So remember, any method can be hidden. We said what? You can hide any method, but you can only override virtual methods. So again, it's giving a warning. Let's see what the warning says. It says derived class.display3 hides the inherited member base class.display3. To make the current member override the implementation, add the override keyword. Otherwise, add the new keyword. Are we clear on this? So this is actually now, by default, it is hiding. What if I leave it at that? What will it do in this case? What if I leave it at that? What will it do in this case? Yes, it will hide it. And if I wanted to override it, what do I need to do?
Add override keyword.
Add the override.
Override.
So we want to do overriding. So we are giving the override keyword. So these are the first, the three things that we talked about. Let me just copy paste that explanation that I wrote down for you all. Okay. All right. So at this point, hiding and overriding seem similar. There's no apparent difference between them. Correct? So let's focus on this now difference. If it's a virtual method, how late binding would work. And to do that, I'll just make another main. And we're going to try out late binding in this example. So for late binding to work, you declare a reference of the base class there. So base class O, for example. But allocate memory for either the base class or the derived class. Right? You allocate memory for either the base class or the derived class. Right? So we'll try out both. Let's first try out base class. Now, when I call the methods, I'm going to call two methods. I'm going to call display2, which is the non-virtual method. So this is non-virtual, which is early bound. And I'm going to also call o.display3, which is the virtual method, which is late bound. Are we clear on this, everybody? Okay, now when I call these methods, the way in which the compiler is calling them is going to change. This line, which is the early bound, this line number 76, depends on how you have declared the reference. So how we declared the reference here in this case? We declared it of type
Base class.
Base class. So the early bound methods will go and call always the display2 from the base class. But the virtual methods, which are late bound, do not depend upon line number 74, do not depend on how they've been declared. Instead, they depend upon what? They depend upon what? What memory has been allocated. So line number 77 does not depend on 74. Instead, it depends on 75. So right now, what am I allocating? I'm actually allocating what? Base class itself. So what method will it call for display3? What
Base
will
class.
it call?
Base class.
Base class method.
Base
What will it
class.
call for display2?
Base class.
Also base class. So far, no difference whatsoever. The difference comes up when you allocate memory for the derived class. And now when you go and call these again, what will line number 81, the non-virtual function, on which line will it depend on? Where will it depend upon? Which line?
Sir,
74.
How it has been declared. So that will not change at all. That will not change at all. But this display 3, which is a virtual method, will be late bound, will depend upon what memory you have allocated. So at runtime, it will evaluate what type of object it's pointing to, and then it will go and call the appropriate method. Are we clear on this, everyone?
Yes, sir.
All right. So let's run this code and check it out. So in the first case, both of them are calling base display 2 and base display 3. In the second case, that is where the difference will be shown. You can now call display 3 will depend upon what memory it is allocated. Are we clear on this?
Yes, sir.
Questions, if any? Somebody was asking me a question earlier about, to explain what virtual is. Have you understood now what is virtual?
Yes, sir. Understood now.
All right.
Can you please repeat it once, sir?
Okay. I'm saying that virtual methods allow for late binding. Non-virtual methods are early bound. That is the basic difference. Late binding implies that what method to call depends upon what memory it is pointing to. So in this first example, if it was O was pointing to base class, when you call O.display3, it will go and call the method from the base class. The same line, if you look at this line, are these lines the same? Is this line the same? Yes. Line number 77 and 82. Is this the same line of code?
Yes, it's same, but first one is for his base
No,
class.
is this line same or not?
Yes.
Line number
Same, sir.
77 and 82, are they the same or not?
Same, sir.
Right. But the difference is in late bound code, even if you write the same code, the function to call will not be always the same. It will depend upon what memory you have allocated. Right? Now, if you look at line number 76 and 81, they are also the same lines, but they will always give you the same output. They will always give you the same output. They will always depend upon what? Upon how you have declared the reference. Are we clear on this?
Yes, sir.
Okay. All right. So let me get back into explanation mode. What did we do out here? We marked this method as virtual. And what did we do for this method? We gave this as override. So when you mark it as virtual and then you override it in the derived class, the method that you're giving as override is also a virtual method. Right? The method that you're giving here as override, is this method also virtual? Yes. The keyword that you're giving is override, but it continues to be virtual. Which means now, like you had, let's say another situation here. Let's say maybe I have, let's say, a class called area manager, which inherits from manager. And let's say the area manager now did not like the code from manager. So the area manager can now again go and override this method again. So how is it overriding it? Again, giving the override key. Can it override this? Is this a virtual method? Is it a virtual method?
Yes.
Yes.
Yes, I just
Yes.
said, I started off my discussion by saying that when you give the override keyword, this method is also a virtual method. So how do you override a virtual method? You give the override. And this again, the virtuality continues. So this method again is virtual. So again, further down the line, you can override it further and further and further and further. And it can go on and on and on. Are we clear on this, everybody? All right, so let's try one such example. What I'm going to do here is I'm going to create another class that inherits from the derived class. So I'll create a class called sub-derived that inherits from the derived class. Now I'm not worried about the the non-virtual methods, so I'm ignoring those. And what am I doing here in this one? I'm again going and overriding this further. Sub-derived class inherits from derived class and it overrides display3 again. Right? So if I have this situation, can I further extend this? O is equal to new sub-derived and go and call this. Do you think this will give me the sub-derived display3?
Yes, sir.
Yes?
Yes, sir.
All right. So you can extend this further. You can, down the hierarchy. You can declare a reference of the base class and allocate memory for any of its sub-derived types. I mean, any of its derived types, all down the hierarchy. And depending upon what you're calling, it will go and call the appropriate. What about display2? Non-virtual function, what about that? That will always remain what? Based
Base
on what
class.
you have declared. So this can go down the hierarchy. Right? So you'll notice that here again, it calls base display3, derived display3, and sub-derived display3. Are we clear on this? Questions, if any? All right. Okay. Let's take this hierarchy. What if there was a class called shape, which had a method called calculate area? Okay. I create a class called quadrilateral. Which also has a calculate area. But what I'm doing here is, of course, I'm overriding it. Okay. Let's say similarly, I have a class called triangle, for example. And this also has a calculate area, which is override. Okay. Let's say I come up with further classes out here. Let's say a class called square and a class called rectangle. Which both of which override calculate area. Okay. So this is the hierarchy, and you can go and create other classes out there. Now, let's take a situation where we have written calculate area first for a shape. So this is the common way of calculating the area for any shape. All quadrilaterals will have this formula and all squares have this formula. Now let's assume that the way in which you calculate the area for a square, it has given you the optimum way of doing that. So there cannot be a better way than this of calculating the area of a square. Okay. Now, what if I create another class that inherits from square? Let's say something that's a square. Let's say maybe a chessboard, let's say. right? All chessboards are square. Now, the square does not want any derived class to further override its method. Why would you come up with that situation? Why would you want to stop it from being overridden? In what scenario would you come across that? You don't want it to be overridden. Why would you not want it to be overridden? Yes, we just said that you have come up with the best way of writing down the code for it. So you don't want your further classes down the line to override it. Because we are saying that this formula or this thing cannot be improved upon. So we don't want people to go and mess with it. So at this point, the square wants to stop this method from being virtual. Virtual methods can be overridden. It wants to stop the virtuality. It's saying up to this point, I want to override it. But after this, I don't want my method to be overridden further. Now, such a method can be declared as a sealed method. So what is a sealed method? A sealed method is a virtual method that cannot be further overridden. So you're overriding that method, but you cannot override that further. All right. So you're stopping its virtuality at this point. So now if I come down to the chessboard and if I try to override calculate area, right, this would give me an error saying that you cannot override something that is sealed. Are we clear on this, everybody?
Yes, sir.
All right. So let's try the same example in our code. Yeah. Was there a question?
Sir, seals method means you can override it only once. They're a little bit confusing.
I'm saying you cannot override it. You cannot override a sealed method.
Okay, okay, sir.
If I don't give sealed, will this work? If I don't give sealed, will this work?
No.
No.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
We
Yes, sir.
can
It will
keep
work.
doing it.
Yes,
No,
sir.
endlessly we can do it. We can keep
Yes,
doing
sir.
override in later classes. So I want to stop it from being overridden further. What do I do in that case? What do I do? I mark it as sealed.
Okay.
So you're stopping it. You're saying now further down, I don't want it to be overridden.
Okay, okay.
Okay. All right.
Yes.
Let's try this. So what I'm going to do here is in my subderived class, I'm going to make this a sealed method. I'll make it a sealed method. Now, if I come up with another class that inherits from subderived, let me come up with another class that inherits from subderived. Let's call this sub-subderived. Right? Let's call this sub-subderived. And in this class, if I try to override this method, it's giving me an error. What is the error it's showing me? Why is it showing me an error? It's saying it cannot override that member because it is, sorry. Display 3 cannot override that member because it is sealed. If it was not sealed, then what would happen? Then override would work. But by sealing it, you're not allowing this to be overridden. Are we clear on this? Everything? All right. So I can remove the override. Will this work now? Will this work?
Yes.
I'm not giving override.
Yes, sir.
What is this doing?
Hiding.
Hide. Can we hide it?
Hiding.
Can we
Yes.
hide?
Yes, yes, we can.
Remember what did we say? Any method can be hidden. But only virtual methods can be overridden. So if you stop it from being virtual, how are you stopping it from being virtual? By giving the sealed keyword. Now you cannot override it anymore. Clear? So
Yes,
would this
sir.
work now? Would this code work? Would it code compile? Would it compile?
Yes, no, sir.
Yes, it will. It's showing me a warning. How do I get rid of the warning?
New.
New. So without new also it works the same way. With new also it works the same way. Only the warning is coming. All right, let's come back here and let's try one more thing. And let's make this sub derived. Right? Sub derived. So my question to you is, what would o.display3 now show? Will it show me sub derived display 3?
No, sir.
No, why not? Why are you saying no?
Sir, because we are hiding.
Because we are hiding it. Because it's no longer being overridden. So when I call this method, any guesses what the output would be? Which method will it call? Display 3 on line number 92. o.display3 on line number 92. What will it call? Any guesses?
Base class display 3.
Okay, I'm not saying right or wrong. I'm just wanted to listen to what you all
Sir,
are.
method of sub-derived class.
Okay. Again, I'm not
It is
saying right or
hiding the base class method, so sub-derived class method.
All right, so I got two answers actually. I got a base class as an answer and I got a sub-derived as an answer. Now the correct answer is sub-derived. Why sub-derived? Because up to this point, it could override it. Up to the sub-derived point. So it will give you the output. The output here that it will give you is the point up to it was where it was last overridden. And it was last overridden in sub-derived. So that's what the output would be. Right? Let's confirm this. So look at the last statement out there. So even if you're calling sub-derived, it's actually giving you only sub-derived. That was your sealed method that you have hidden in the sub-derived class. Are we clear on this? All right.
Sir, can you explain once again?
Yes, sir.
Which part?
Sir, that sub-derived part. I mean, I am not getting why the method of sub-derived is not called.
It would be called if you were overriding it. So if you override it, it will get called. Let's see this output first. If you override it, it would get called. Okay. Let's establish that first. So by overriding it, it is getting called.
Yes, sir.
Okay. So these are, this sort of thing is possible if you override it. When you say sealed, what does seal do?
It will stop the.
Sorry, not here. I want to do it here. What does seal do?
It will stop overriding of the method.
Yeah. So it's saying up to this point it is virtual. After this point, it is no longer virtual. This is what it's saying. It's stopping that function from being virtual after this function, after this class is over. Up to this point, it's virtual, but after this, it is not virtual. So moment you're saying that this is sealed and it is not virtual anymore, in the sub-derived, this is giving me an error.
Yes, sir.
So I cannot override it.
Yes, sir.
So when I can't override it, what is it doing by default? What is it doing by default? Hiding it. So now when I try late binding, here, this will give me the output of the last place where it was overridden.
Okay, sir, got it.
And the last place where it was overridden was the subderived.
Subderived, yes, sir.
So this output will show me subderived.
Yes, sir.
All right. So this is what I was trying to show you.
Yes, sir. Thank you, sir.
So,
Yes.
so you mentioned that we stop a function from being virtual so that we need not implement it, like its implementation is the best at that point.
Correct.
But then by using this hide method also, we are re-implementing it.
But what did I tell you right at the start? You're conveniently remembered the second part of my statement. The first one that in fact, I had even written down here. I had even written down, sorry, not this one here. I'd even written down here.
But then we can choose not to do that, no? Because anyway, we are re-implementing it. So it is like a segue.
See, what we are trying to say is late binding will be stopped. You cannot overriding it. You are preventing it from being overridden further.
Okay, so late
So
binding stopping is the
yeah,
main
so
point.
whenever now, if you come back to this hierarchy here, if you come back to the hierarchy here, if you declare a reference of type shape, if you declare a reference of type shape, but allocate memory for chessboard, what method will it call?
Square.
Square. So that's what square wants. Square says, okay, no, now no further can be overridden further.
Okay, understood, sir. Thanks.
Okay. Yeah. Any other query?
So what would we write in the last sub-derived class? What would we write in the body of the method? Or
You
did
write
we?
your own code, no? I mean, see, late binding will not work. Late binding will not work. But you cannot, I mean, say that you can't prevent that later class from writing its own code in any way. That case, like that was the same question that the girl asked me before this. Can we go and hide the method? Of course you can. You can hide any method. So whatever code that it wants to write. So if chessboard, for example, in this example, if chessboard wants to participate in late binding, then it cannot override squares method. But if you create a chessboard class on its own and it says, no, I don't want the parent class method, I want my method to be called, then fair enough. You can't, parent class can't prevent that.
So, but still we are getting the implementation as like when you called it, we were getting sub-derived, or like the message we were getting was sub-derived, right?
In late binding. In late binding. Without late binding. Supposing I declare a variable of type chessboard. Or in your case, sub-derived class. And I call that display 3 method, then it will call sub-derived. Okay.
Okay.
All right. Now I'll come back to this code of mine. And I'm going to make a statement right now. You all have to tell me whether the statement that I'm making is correct or false. Okay. So you have to justify to me what your opinion of my statement is. So the statement I'm making is that this for a sealed function, the sealed keyword must compulsorily be used in combination with override. All right. The statement I'm making, I'll repeat my statement. I'm saying for a sealed function, for a sealed method, the sealed keyword must compulsorily come with the override keyword. That is the statement I'm making. Now you have to say either the statement that I'm making is true or the statement that I'm making is false.
True.
But you have to justify your answer either way, either true or false. Whatever you're saying, you have to justify your answer. Yes.
True, sir.
So you're saying no, it's not true.
It's true, sir.
It's true. Why is it
Yes.
true? Why is it?
Because you don't write override, it will be hidden.
No, I'm giving.
Sir,
I'm
it's-
saying, listen to my statement again. 1 second. Let me interrupt the person who's giving the answer. Let me interrupt for a second. I'm saying that the sealed keyword must compulsorily be given with the override. Yes. What was the some girl
Yes,
was
sir,
answering?
it should be true because we can only seal a virtual method.
Okay. And
Override means we are using a virtual method and hence it should come. Because in the very first method, virtual, if we are using seal, it doesn't make any sense.
beautiful. Who's this girl who answered? What is your name?
Devi, sir. Yes.
Superb. Very well
Thank you, sir.
answered. I could not have answered it better myself.
Thank you, sir.
All right. So have you guys understood what Devi said?
Yes, sir.
Devi, once again, I liked your answer so much. I'm going to ask you to repeat it. Please say it again.
So we can only seal a method which is virtual in nature.
Okay.
And
Full stop.
override.
1 second. She's saying that you can only seal a method which is virtual. Agree? Everybody? Only a virtual method can be sealed.
Yes, sir.
Okay. Carry on, Devi.
So when we are overriding a method, that means it is essentially a virtual method and hence it can be sealed. But the very first time we are mentioning that a method is virtual, if we are using sealed there, it doesn't make any sense because then that method is not virtual anymore.
Okay, very well done. Is there anybody sitting next to you in your room or whatever?
No, sir, I'm alone in my room.
I would have asked you to go to them and ask them to pat you on the back.
Okay.
Okay, so maybe later in the evening you can do
Okay,
that.
sir. Thank you.
Okay, so what can you seal? You can seal a virtual method. What are the two ways of giving a method as virtual? Either you say virtual, or you say override. Correct? Now imagine if you went and said sealed virtual. Imagine if you said sealed virtual. This doesn't make sense. What does virtual say? What does virtual say? That you can override it further. And what does sealed say? What does sealed say?
You can't override.
You cannot.
Override further.
So both of them are contradictory. So both of them cannot be given. So it gives you an error here saying that you can't say sealed virtual. So now if you can't do sealed virtual, what is the only possibility left? What is the only possibility left?
Sealed override.
Sealed override. So this is what I was saying, that you can only give sealed with the in combination with override. By itself, you cannot give sealed. By itself, you cannot give sealed. That is what I was trying to tell. Okay. All right. Now, when you use virtual methods, you're using late binding, right? You're using late binding. So when you're using late binding and you're using virtual methods, will your code run faster or slower than if you're using early bound methods? For virtual methods, will your code work faster or slower than early bound methods?
Slower.
So yeah, why slower? Correct? Why slower? Why would it be slow?
Early binding is one-step process. Late binding, first it will check for reference, then for object.
Correct. So every time you call a method at runtime, it will check what type of object it is. And based on what type of object it is, it will then go and call the method. Whereas with early bound code, initially itself, you know what to call. So late binding works slower than early binding, but late binding is more flexible. All right. So in certain cases, you might need late binding. In certain cases, you may not need late binding. Are we clear on this, everybody? All right. Now, today's concepts that you learned so far, I mean, first 2 days you learned, you were, okay, this is very simple. We know this is in Java, this is in Java, this is okay, this is okay, this is okay, this is okay. Today, when I started talking about hiding and overriding, it was a culture shock to you all. You're like, what is he talking about? We know when you give a method in the derived class having the same name, we know it is overriding. So why is he talking about hiding? What is this new funda of hiding that has come up? Because in Java, you have learned that when you give a function having the same name in the derived class, what is that? In Java, what have you called it? What are you doing? Overriding. Overriding, right? And here suddenly we now were exposed to two aspects. We are saying no, it could be hidden or it could be overridden. So there are two different ways. So why did it, or why is it different in C# or in .NET from what you have learned in Java? What is the basic difference between the two? What is the basic difference between the two? Why is this new concept coming here, which was not there earlier? Yes. Right. The answer is because in Java, by default, all methods are virtual. And in .NET, by default, all methods are not virtual. So in .NET, if you want to make a method virtual, you have to give it a keyword virtual. In Java, you didn't need to do that. In Java, what happened? All your methods were virtual. So when you gave another method in the derived class, without needing to give any keyword, what were you doing there? You were overriding it. In .NET, what happened now? In .NET, if the method was not marked as virtual, you were hiding it. And if you are wanting to make the method virtual, you made it virtual and then you have to use the keyword override. Because if you don't use override, it hides. So that is the difference. That is the reason why your funda in Java and in .NET was different. Are we clear on this, everybody? All right. I kept saying right from day one, I've been saying that .NET code runs much better, much faster, better performance. So .NET had the benefit of coming in after Java. So it looked, okay, there is a language that has been created based on C++ called Java. And these are the issues with Java. So how can I improve them? So .NET had that benefit of first looking at what mistakes somebody else has done and then correcting it. So which is why one of the decisions they took in .NET was that by default, all methods will not be virtual. Why? Why have they taken this decision? Why are they saying by default, all methods are not virtual?
So because all virtual methods are late bound methods. And which will slow down the process.
So if you don't have a virtual method, your performance would be automatically better. Right? So part of the improved performance in .NET is due to this fact. Because all methods by default are early bound, and whichever you want to participate in late binding, you make them virtual. In Java, it's the reverse. By default, everything is late bound. Are we clear on this, everybody? So even if you don't need late binding, you're still slowing down your code in Java. All right. So focus on these differences when even when you go for an interview or whatever. Knowing the code is okay, one aspect, but why things happen? Always when you're learning something, the first question that you have to ask yourself is why? Why am I doing it this way? If you understand the why, then the how becomes simple. All right. All right. So this is to do with late binding and virtual functions. Let's take this further. Moving on to another concept in inheritance. Okay. Let's assume you had this employee class that you created the other day, right? So you had common properties for the employee coming in here, like you had an employee number and name and what else, basic and department number, and then you had the method get net salary. So all the common properties that you had in an employee would go in here. Now let's assume that from this employee class, we create other classes that inherit from employee, and all possible types of employees in an organization, we create a class for that. So for example, we might create a clerk class. We might create a salesman class. We might create a whatever, let's say officer class. We might create a manager class, and whatever else. Let's say programmer class, the most important employee of all right? Let's say a CEO, and all possible types of employees that you can think of, you have created here. Okay, whatever possible types of employees are there in the organization, you have created a class for that. Right? Now, in such a scenario, can I create, or would I need to create an object of the employee class? Would I need to create an object of the employee class? Yeah.
No.
Why not? Why not? If you're saying no, then why not? Why would I not need to create an object of the employee class in this scenario? Yes.
So employee in itself would not have any kind of implementation, and all the implementation would be in rather like like child classes like clerk and salesman. That's, I think.
So think about it this way: in an organization, if every type of employee, if there is a class for that, then what will this guy do? You're saying he's an employee, but what is he doing? He has to perform some role, no? He has to be either a clerk or a salesman or an officer or some other employee. He cannot be just coming in there, taking a salary and going home. He has to perform some job there. No? So what job is he performing? He has to be one of the specific types. So do you agree that there is no need to create an object of the employee class? We don't need to create an object of the employee class because we'll be creating an object of one of the derived classes. So if we don't need to create an object of the employee class, if I don't need to create an object of the employee class, why don't I just delete the employee class? Why don't I just delete the employee class? Can I just delete the employee class? Yes. Can I remove the employee? I'm saying I don't need to create an object of that class. Let's delete the employee class. Yes, no, what?
No, sir.
So you use some basics that is available in employee.
Right. So the reason we don't want to delete it is because the common properties would go into the employee class.
Like name.
Right. Whatever common properties, name, employee number, basic salary, whatever else that is common would go into the employee class. So we need the employee class for giving rise to further classes. Other classes will inherit from employee and get these properties. So we don't need to rewrite our code at multiple places. But we don't want to create an object of the employee class. Now, such classes can be marked as abstract classes. An abstract class will not be instantiated. You will not be creating an object of the class. but you could use this class for giving rise to newer classes. For other classes can inherit from the abstract class. So common properties would be put into the abstract class, and you would have derived classes that inherit from there. But what would not be possible would be instantiating the abstract class. To create an abstract class in .NET, you need to use the keyword abstract. So you would say public abstract class name, and that would create an abstract class for you. Right? Right? This would create an abstract class for you. Right? Stop. End of the discussion out here on what is an abstract class. So an abstract class is one that cannot be instantiated, but what? But can be used as a base class. Right? You can inherit from that class. Now, optionally, additionally, and optionally, an abstract class may have abstract methods in it. I'm saying optionally, it's not compulsory. An abstract class may have abstract methods in it. So what is an abstract method? An abstract method is a pure virtual function. In object-oriented terms, an abstract method is a pure virtual function. So what's a pure virtual function? All pure virtual functions to begin with are virtual functions. All pure virtual functions to begin with are what? Are virtual functions. Meaning what? When I say virtual functions, what should come to mind?
Compulsion to override.
No, virtual function I'm
compulsion.
asking about. What is a feature of a virtual function? That it is late bound. Right? Runtime binding, runtime polymorphism. That is what you mean by virtual function. So I'm saying all pure virtual functions are virtual functions. Now, what is the pure part of it? What do you mean by the pure virtual function? A pure virtual function is a virtual function which does not have a code body in the abstract class. It only has its signature. So if you're writing code in C++, you could write a pure virtual function by specifying it's a virtual function and giving equal to 0. That's how you did it in C++. In Java, of course, you have the abstract keyword. So I'm saying all abstract functions are actually what? Object-oriented term for them is what? Is a pure virtual function. And a pure virtual function is a virtual function which only has its signature and does not have its code over. Are we clear on this, everybody? Furthermore, when you declare a pure virtual function in an abstract class, and if you have a derived class implementing that abstract class, if you inherit from that abstract class, then it becomes compulsory for the derived class to go and put in the body for the abstract function. All right. So this becomes compulsory out here. Okay. Now we have said this already. An abstract class need not have a pure virtual function, need not have an abstract function. An abstract class optionally may have an abstract function in it. Not compulsory. It is optional to have an abstract function in an abstract class. But the reverse is true. If a class has an abstract function in it, then the class must be abstract. If a class has an abstract function in it, then the class must be marked as abstract. So abstract functions can only exist in abstract classes. But all abstract classes don't need to have abstract functions in them. Are we clear on this, everybody? So this is where .NET
Yes, sir.
and Java differ from C++. In C++, you can make a class abstract by adding at least one pure virtual function in C++. In Java and .NET, that is not the case. They have removed that. So in C++, to make the class abstract, you have to have at least one function, abstract function in it, pure virtual function. In Java and .NET, that is not the case. Are we clear on this?
Yes, sir.
Questions, if any, about any of what we have discussed? You have the benefit of having tried this out in Java, right? So I still go through the discussion again because not everybody remembers what they've done in Java. So those who don't remember what you've done in Java, listen to these concepts well, and you will, recap some of the things that you've done in Java. All right. So we have almost out of time. We'll take a break at this point of time. When we come back from the break, we will put into code whatever we have just said in all of these last few minutes about abstract classes. We'll try that out. All right. Any last questions before we disconnect? All right, then I'll see you all at 12:30 and we will jump into the code at that point of time. Bye. Okay, so we've just tried out virtual methods and then we spoke about abstract classes. So let's take it further and try out abstract classes out here. Okay. Let me again copy paste some code from my existing code to help speed up things. All right. So we said an abstract class could be created with an abstract keyword. That's how you would actually create an abstract class. In the first example that I've taken up, my abstract class does not have any abstract methods. It only has non-abstract methods, right? If I try creating an object of that abstract class, this is not allowed for me. I'm not allowed to instantiate an abstract class. So that's the first thing that we have checked out for. But what is possible here, of course, is we can create a derived class that inherits from the abstract class. So what does the derived class now get? All the members from the abstract class. So this is just like any other regular inheritance mechanism that you have. Okay. You could, of course, create an object of the derived class. And if you look at obj dot, this will give you all the members of the derived class plus those of the base class. Are we clear on the first aspect out here of declaring an abstract class and inheriting from there? Any questions about this? All right. So let's try the second example. In the second example, I have an abstract class which has abstract methods. Okay. When you create an abstract method, you would give the signature. Firstly, you'll use the abstract keyword. You'd give the signature, but you will end it with a semicolon and not have a code body in there. So abstract methods are, just purely the signatures in there. When you create a class that inherits from the abstract class, let's say I created class 2 that inherits from the abstract class. Currently, it's giving me an error. And the error is because this class now is forced to write down the implementation code of the abstract methods. So just the signatures come in here, and then the derived class is forced to write down the implementation code. The error shown here is that it does not implement display and does not implement, show. Now remember, these methods are another term that we use for abstract methods are what? Object-oriented term. Correct object-oriented term is what? Are what type of functions?
Pure virtual.
Pure virtual functions. So they're also abstract. They're also, virtual functions. How do you override a virtual function? What keyword do you use in .NET? Yes. Override. So here also, when I start typing this out and I say public override, now when I give a space here, what is it prompting me with? What is it showing me here? What functions is it showing me?
The display and show.
Yes, but what type of functions are these?
Virtual functions.
These are either virtual or abstract functions. Right? So another word for abstract, of course, is pure virtual. So these are either virtual or pure virtual functions, right? From the base class. So equals, get hash code, and toString are virtual functions, but display and show are abstract functions. So both of these would be shown here. Now, if I write down code for display, look here for a second, everybody. When I write down code for display, if I select this, it's just, giving me some code which says not implemented, and I have to replace that code. Similarly, I'll have to do the same thing for what? Just like I've done for display, I'll have to also do it for
Show.
show. Now, assuming what if, I'm just giving you a imaginary situation. What if instead of 2 functions, what if that class had 20 functions? Now you would have to write down the code for all of the 20 one by one. Now, instead of you writing down the code, Visual Studio helps you generate the code. So see what I'm doing next. Instead of writing it down this way, you move your mouse pointer on this, and there's an option here which says implement the abstract class. So I'm asking you to do what? Do not go and write down the code. Instead, the easier option is to do what? Just go down here and choose implement that abstract class. Are we clear on this? Don't blindly write down the code. Just implement it. So the code is generated for you. And then of course you can go and change this code. Whatever now you want to put in that method, that will be your code. Don't sit and write down all the methods one by one. I'll do it one more time. Move a mouse pointer on that and implement the abstract class. Are we clear on this, everybody?
Yes, sir.
All right. Now, what if I have an abstract method and I don't mark the class as abstract? Then what happens? We have said this before, that all abstract methods must be contained in a
Abstract class.
Abstract class, right? So that becomes compulsory. But an abstract class need not have
Abstract method.
Abstract methods, right? Okay. All right. Now let's take another scenario. This is a derived class, so it's overriding all the methods. So what if I don't override all the methods? Which means that one of the methods in here is an abstract method. I've got display, which I've overridden, but show is still an abstract method. Now, you may want to, in certain situations, mark this class also as abstract. Right? So what happens now here is the compilation error goes away, because now you got an abstract method in an abstract class. So you may even have situations like this, wherein your derived class may not implement all the methods, might implement only some of them. But then in that case, your derived class needs to be an abstract class, since it doesn't have all the methods in there. And then if you have a sub-derived class, then the remaining methods can be implemented in the sub-derived class. So this is also a possibility. Just be aware of that. Right? I'll keep my example the way I have out here. So I have taken two examples. One, an abstract class which does not have abstract methods, and secondly, an abstract class which has abstract methods. Any questions, any doubts about any of this, or I will move on to the next topic at hand. Yes.
So why are we writing abstract if there is no unimplemented method in the class?
I'm not here.
So not in the first one.
I'm preventing an object of the class being created.
Okay.
I gave you the example of the employee class to begin with.
Yes, sir. Yes,
And
sir.
I said that the employee class will have certain code in it, and it may or may not have abstract methods. But I don't want an object of that class to be created.
Okay, sir.
Yeah. Any other queries before we move on? All right. So just to summarize, if you have an abstract class, what is possible? What can you do and what can you not do? Can you instantiate the class?
No.
No, sir.
No, sir.
No, sir.
Yeah, the answer is no. Can you inherit from the class?
Yes.
Yes.
And the answer is yes. So that's just to summarize what we're doing with an abstract class. Now, instead of an abstract class, you have another type of class here called as a sealed class. A sealed class is an exact opposite of the abstract class. A sealed class is an exact opposite of the abstract class. So help me define what is a sealed class. Help me define what is a sealed class. Yes.
Class whose instance can be created, but we can't inherit from that class.
Perfect.
It is the derived class of the abstract class.
No. No. First one, we'll stick to the first one. A sealed class is a class which you can instantiate. You can instantiate, but you cannot inherit from. It cannot be used as a base class. Right? It is an exact opposite of the abstract class. So whatever is yes in the abstract class becomes no in the sealed class. Whatever is no in the abstract class becomes yes in the sealed class. The keyword to create a sealed class is sealed. So how will you create a sealed class? Give me the syntax for creating a sealed class.
Public sealed class name.
Perfect. Public sealed class name. That creates a sealed class for you. So to do for you, I'm not going to do this. To do, create a sealed class. Right? When you create a sealed class, what will you try to do from there? You'll try to create an object first, and that should work. Secondly, what will you try to do? You will use it as a base class. and that will not be allowed. So that will give you a compilation error. So these are the things that you have to try out. Now, in what situations or what circumstances do you need to create a sealed class? This is how you do it. But why do you need a sealed class? In what situations would you need a sealed class? Typically, a sealed class actually goes against object-oriented principles. Object-oriented principles are all aimed towards what? Why are we writing object-oriented code? Main reason is what?
Code reusability.
Reusability of your code. But this is preventing code reusability. This is preventing your code from being reused. So sealed classes came in much later. When C++ was written, they didn't have a concept of a sealed class. These modern day programming languages have introduced sealed classes. And this is more to do with commercial angle than with object-oriented angle. Commercial angle meaning what? Supposing I write a class and I give you my class to use. Now you can very easily inherit from my class and create your own class and sell your software. So if I've given you some software, you use my software, you inherit from my class and you recreate and you sell it as your software. So I don't want that to happen. So what do I do then? I can create a class that is sealed. So you will be able to create an object of my class, but you won't be able to reuse my code through inheritance. So that is the thinking behind this. If you don't want your code to be reused, you create it as sealed. So it's not a very noble objective. It is more to protect your own interests. All right. That's your sealed class out here. Are we clear on this?
What are practical uses of sealed classes?
I just went over that.
Okay.
Can someone please answer the question for me? Why create a sealed class? Why should you create a sealed class? In what situations are you creating a sealed class? What are the practical uses of a sealed class? Would someone like to answer the question for me?
To restrict the code reusability.
To prevent inheritance.
So if you have written some very good code that you don't want anybody to reuse, you create it as a sealed class. As simple as that.
Okay, sir.
Practical uses are prevent someone from copying your code. Copying your code meaning inheriting from your class and just selling it as their own. Okay. All right. Now, most modern day programming languages do not allow multiple inheritance in their code. And, in fact, somebody asked me a question also earlier and they said, why is it not allowed? And I said, we'll have a discussion on that a little later. So here is where we are having the discussion. So consider these couple of situations. I'll just give you a couple of situations and I'll tell you, we'll discuss what could be the problems in the code. Let's assume you had a class called person, right? And a person had two properties, let's say name and age, for example. And name property, says that it should be a proper name and all that. So, code for that. And age must be greater than 0 or greater than equal to 0. Let's say a person who's born in completed years, his age is 0 years. So let's say this is the restriction that I put out here, that the minimum age for a person should be 0. Right? Oh, thank you for reminding me. I'll get up in a minute. 2 minutes more, I can carry on. Thank you for reminding me. Let's take another, called employee, which inherits from person. So what would be, whatever the properties that are there in a person comes into an employee class. All right? No. Dheeraj, no. Okay, two things. No direct messages to me, please. And secondly, please ask your question. I have given you enough opportunities to ask a question. I don't want you to type out like this. Don't make me break my flow and having to go into the chat window and this thing. All right. So answer is no. Do not, firstly, no direct messages, because anyway, even if you give me a direct message, I'm sure, opening that window and everybody can see it. Second thing is no typing out anything in the chat window. Please talk to me. Right? Okay, coming back to this class employee, which inherits from person, gets all the properties of person, but in an employee, let's say the restriction is that age should be minimum 18 years old, right? You need to be an adult before you can be an employee of anyone. Child labor is not allowed. Okay. Let's assume there's another class that we create called student. So all students also inherit from person. And for a student, what could be the minimum age? Minimum age in this case. Let's say you're taking admission to whatever nursery or playgroup or whatever. Nowadays they allow two-year-olds also there. 1 year, 1.5 year also there. But let's take 2 years. If you want to join a playgroup, your child needs to be minimum 2 years old. Let's take that as a mistake. So let's say there is a restriction that minimum age should be 2 years. Okay. Now, what if I create a class called trainee employee, which inherits from employee as well as from student? Okay, so when you join an organization, for example, in a couple of months, you'll be joining an organization. Maybe initially they give you a training. 2-3 months they give you training before you can actually do any productive work. So at that point, you're a trainee. So at that point, you're inheriting from employee also, and you're inheriting from student also. Now, in this case, do you see a problem? Do you see any problem in here?
Yes, sir.
Triple validation for same property.
Right? First thing is you're getting 2 copies of name and age. You're getting 1 copy through employee, and you're getting 1 more copy through person. Now, name is okay. It's got the same code for both of them. But if you look at the code for age, there are 2 copies of code that you're getting. You're getting a copy of code which says that age should be minimum 18, and you're getting a copy of code which says age should be minimum 2. So what should be the copy that you will retain? That becomes an ambiguous selection. You're not sure which one to retain. You're not sure means you know what to retain, but the compiler doesn't know what to retain. Compiler says that, okay, there are 2 copies. Now, how do I know what to resolve? So this is ambiguous code. You're not sure which one to call. And it's not easy to resolve this by setting certain rules right at the beginning. It's impossible to do that. So the moment you go into multiple inheritance, you're faced with this sort of problem. I'll give you another example. You're not going to be just creating objects in code. You're going to be creating visual objects also, right? So let's say, for example, you have a class called window. Okay, you have a class called window. So all windows inherit from the window class. You create another class here called window 1. Okay, you create a class that inherits from window, and let's say we call it window 1. Right? Now, every window has certain characteristics. Like, for example, it might have a height, it might have a width, and it might have, let's say, a background color. So let's say this has a background color of red. Now you're going to change this code in this class, and you're given it a background color of yellow, and it has a different height and width, let's say. Now you create another window, right? You create another class called window 2, which has a different height and width. Let's say we give this a different color, background color. So let's say this one has a background color of blue. Now I create another window class that inherits from window 1 and window 2. Right? It inherits from window 1 and window 2. So can you see what the problem would be?
Diamond.
Diamond.
So you're getting now again multiple copies of code out here. Like there's a property for height, there's a property for width, there's a back color. So this new window that you created, what should be the height of this window? It should be the height of first window or second window. Or what should be the background color? Should be yellow or blue, or a combination of yellow, blue, and make it green. What do you want to do? Right? So do you see the inherent problems with multiple inheritance? Yes. So these are the problems that you face. Now, why are you facing the problems? What is the reason for the problem in multiple inheritance? What is the problem in multiple inheritance?
Same field with different properties in different classes.
Yeah, so when you're saying properties, those are actually functions. All right. And in the functions, you've actually written some code. Agree or no? Basically, the code that you write here is different. When you're saying this property is different, the code that you've written here is different. You've written a different if here, you've written a different if here. So the problem in multiple inheritance is you're getting 2 copies of code. And when you get these 2 copies of code, which copy to retain becomes a problem. Agree?
Yes, sir.
Yeah?
Yes, sir.
All right. Now let me provide you with another alternative. Let me give you another situation. Right? What if I had created a class called employee? Right? So now this employee class has some properties in there. You'll know the employee class. You'll have created that yesterday. Same class I'm talking about. Okay. And I create an abstract class, let's say DB functions, which has only abstract methods. So this is not syntactically correct, but you'll understand what I'm doing out here. This is only abstract methods. So let's say insert, update, and delete. So these are methods that I would work with when I'm working with a database. Right? So I'm creating an abstract class with only abstract methods. And now I want to create a class manager which inherits from employee as well as from DB functions. I want to create a class which inherits from employee and DB functions. Now, in this particular scenario, would you face a problem? Would you face any problem?
No, sir.
Why not? Why not? Why would you not face a problem with multiple inheritance here?
Because there is nothing in employee class.
There is no chance of creating 2 copies.
Why is there no chance of getting 2 copies?
No ambiguity.
Why no ambiguity?
Because all the member functions are different.
Okay, what if employee also had some member functions called insert, update, delete? Then will there be ambiguity?
Yes.
Yes.
No, sir.
No, sir.
Will you
Like,
get multiple copies of code?
No, implementation
No, sir. Only
this
one.
DB function class is not provided.
Assuming employee also had those same member functions, are you going to get multiple copies of code?
No, sir.
No, sir.
No,
But
code
Why
will-
No,
not?
sir.
Why not?
implementation will be only one.
Yes, sir.
Because in this, I have created abstract methods, they don't have any code in them. So the problem came up for you when you had 2 copies of code. What if I tell you that I'm not giving you any code at all? I'm only giving you a signature. I'm not giving you one more copy of code. So will there be an ambiguity now? You agree there's no ambiguity now? In the first case, I actually gave you 2 copies of code. So which copy to retain you became a problem for you. Now, if I'm not giving you a copy of code, I'm giving you only a signature. Then even if employee has the code, you'll get only 1 copy of code. At the most, supposing employee had some method also called insert update delete. In my derived class, I'll only get 1 copy of code. I will not get 2 copies of code. And if employee didn't have that code, then I'm getting only the signature and I have to write the code myself in any case. So there is no chance of ambiguities happening. There is no chance of duplications happening. Do you agree with this assessment or not?
Yes, sir.
Yes, sir.
So what we are saying is that if you have an abstract class with all abstract methods, in this scenario, in this particular scenario, multiple inheritance will not cause you a problem. This is what we have said. But any other scenario and multiple inheritance could cause you problems.
Sir, what about variables?
I'm saying that there are none.
Okay.
I'm giving you this situation. I'm saying that this class only has what? Only has what?
Abstract methods.
Abstract methods. I'm asking you to assume that. And I'm saying now will you face a problem? And the answer is no. Now you would not face a problem. Now it is very difficult for the compiler to build in a rule like this, saying that I will allow multiple inheritance, but I will have to first check that the abstract class has only abstract methods. Are you getting what I'm trying to say? Why? Because assuming you first allow it, and then later they go and change the code. They go and make one of the methods a non-abstract. Or like he said, what if I introduce some variables out there? Because the abstract class can have other things in there. There's no restriction on the abstract class itself, right? So it becomes very difficult to keep a check like that. So to take care of this situation or to allow this particular situation, the concept of an interface was introduced. And what is an interface? An interface is like an abstract class with all abstract methods. What is an interface? An interface is something that is like an abstract class with all abstract methods. In other words, we will only have signatures in them. We will not have any code in them. So now what we are saying is, instead of creating this as an abstract class, we will create this as an interface. So we'll call this as an interface. And the interface now typically will have only what? Only what?
Only abstract method.
Abstract method.
Method signatures.
Only method signatures.
And if this is what is there, then this should be allowed.
Hello, sir.
Yes.
Hello, sir. Could you please explain that previous part? I didn't understand it.
Okay, I'll come back to that. All right. So what I was just saying was this, that an interface is like an abstract class with all abstract methods. Only the signatures should be there. And if this is what you have, that you're only getting the signatures, then it does not cause any ambiguities. And therefore, something like this would be allowed. So instead of calling it an abstract class with all abstract methods, what are we calling this? An abstract class with all abstract methods. We are coding it and calling it an interface. All right. So now an interface which has only the method signatures, you can, the term you are used is you can implement more than one interface. So you can inherit from one class only. Again, that is still true. You can only have single inheritance. You can only inherit from one class, but you can implement more than one interface in addition to that class that you inherit from. And this is what is allowed in most modern day programming languages. So my first question to you is, if this is what we are saying, that interfaces can contain only signatures and not any other code, if that is what we are saying, all right? And what statement am I starting off with? If interfaces can contain only code and not signatures, then are interfaces a replacement for multiple inheritance? Are interfaces a replacement for multiple inheritance? That whatever you could do with multiple inheritance, now you can do with interfaces. Is that statement, do you agree with the statement or not?
Yes.
Yes.
Yes, sir. Yes, sir.
I don't agree with it. When we started off on the topic of inheritance, I asked you all, why have inheritance? What was your answer?
Code reusability.
Code reusability. I need to get the... All right. So I got my charger back on. So why have inheritance? Code reusability. When you're writing interfaces, are you writing any code in there?
No, sir.
What are we giving in there?
Only method declaration,
Only
signature.
Only the
signature.
signatures. So are you getting any code reusability here?
No, sir.
So are interfaces a replacement for multiple inheritance? Are they a substitute for multiple inheritance? Can they be a substitute for that?
Yes, sir.
No.
Sir, not a complete
No,
replacement.
sir.
Partially, sir. We can say partially.
I'm not saying partially. True or false? Yes or no?
No.
Are they a replacement for multiple inheritance? Can we, whatever can we do with multiple inheritance, can we do with interfaces? Yes, I'm asking you.
No, sir.
No, sir.
No, sir.
So I don't blame you for giving a yes answer, because you have been programmed into thinking, or you have been, books or whatever, wherever you read or somebody's told you that, oh, this language does not have multiple inheritance, but it has interfaces. Which implies that, okay, whatever multiple inheritance can do, we can do it with the interface. But that is not the case, right? So interfaces are not a substitute for multiple inheritance. Somebody said they give you some of the features, partly. So they're not a substitute. Substitute would be something that can give you everything that you want to. So now the question is, if they cannot give you everything that multiple inheritance gives you, they are not a substitute. Are they important in their own way? And the answer is yes. In their own stead, they are very important. They play a very important role. Do you need interfaces in your code for doing things other than multiple inheritance? Of course you need them. They play a very, very important role. We'll talk about what roles. Let me first, I know you all have worked with interface, I know that, but I prefer working on the assumption that you don't know what I'm talking about. All right. So they are important in their own way. They are very important in their own way. But they are not a replacement for multiple inheritance. They cannot do what multiple inheritance can do. I'll give you a cricket example. No, we went and we beat Australia in Australia. Right? Was Pujara important to our efforts? Was Pujara?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
Of course, sir.
Okay. Was Rishabh Pant also very important in our efforts?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir, sure.
All right. Could Rishabh Pant do what Pujara did?
No.
No, sir.
No, sir.
What did Pujara do? He basically just kept, putting the ball back. I mean, batting the ball back. So 30-40 overs, people are bowling to him and he's not just able to get him out. So they got tired and then Rishabh Pant would come and destroy the bowling. Could Pujara do what Pant did?
No, sir.
No, sir.
No,
No,
sir.
he didn't. So is Pujara important?
Yes.
Yes.
Yes, sir.
Yes.
Is Pant important?
Yes.
sir.
Yes.
Yes.
Is Pant the replacement for Pujara?
No.
No.
No, sir.
No.
So similar situation here. Interfaces are not a replacement for multiple inheritance, but they are very important in their own way. So we'll talk about why they are important a little later. Now, when you use an interface, when you have a class implementing an interface, it becomes a contract between the class and the interface. And the contract is that the class must compulsorily write down the code for all the methods in the interface. So quite often it's like a contract. The contract is something that you must do. Right? So all the methods in the interface must be implemented by the class. That's the first thing. Now, how does that help us? Or where does that help us? Where is this useful? Quite often in large projects where you have got multiple programmers working, you won't be working one person on one project. There'll be a large team, maybe 15, 20, 30, I don't know how many people, depending upon the size of the project. So what the project manager can do is he can create an interface, specify what the methods that are there in the interface, and ask you all to write classes that implement that interface. Now, when you write a class that is implementing the interface, what is happening there? What are you forced to do?
To provide implementation of unimplemented method from interfaces.
Correct. So you're forced to write down the code for all the methods. So the project manager is sure that if you're implementing the interface, then you're also writing down the code for the method. So that's the first thing that you're getting out there. Second thing that you're getting, second advantage that you're getting in a large project again, is that supposing the interface is a method here called insert, update, and delete. Now, all of you all implement this interface. So what will your methods be called in your class? What will they be called if all of you all are implementing the interface? They'll be now called what? Insert, update, and delete only. Supposing this is the interface that you're implementing, your class is implementing that. Even if you create different classes, all your method names and signatures will be the same. Agree or no?
Agree.
Yes.
Yes, sir.
Yes.
So if I have to call code on any of your classes, then I know what code to call. If I've used one class, then I know how to call the code on the other class. Because the other class also will have the same method name. So what happens there is you get polymorphic code. What is polymorphic code? Code that looks the same, but depending upon the object that you're calling it on, it behaves differently. So interfaces allow you to write polymorphic code. Right? That's another advantage. Thirdly, quite often in different situations, in different projects, in different situations, you might be faced with a particular type of problem. And to solve that problem, you'd be writing code in a certain way using a certain pattern. Now, when you do it repeatedly and you're using the same type of pattern, this typically can be implemented as a design pattern. So design pattern is a style of coding that you implement while you're writing code. And there are different design patterns. So in different projects, if you're faced with a situation, you might be using a particular design pattern. And these design patterns are implemented mainly with the use of interfaces. So you would have been exposed to certain design patterns, maybe a factory design pattern, for example. And as you go along in your code, see, right now you're just in a stage where you're learning code. You're learning about Java, you're learning about .NET. So maybe as you go along, maybe 1 year, 2 years, 3 years down the line, you'll be understanding these design patterns a lot better, right? And design patterns are implemented with the help of interfaces. So there also, in the structure of your code and the way in which you write code, interfaces play a very big deal. So these are some of the places where interfaces would be used. These are some of the advantages of using interfaces, not as a substitute for multiple inheritance. Very important by itself. So if multiple inheritance is your pujara, interfaces are your panth. Won't support, won't replace the other one, but will play a very important role nevertheless. Are we clear on this, everyone? So let's try out a few examples with interfaces and see how you can work with interfaces. Any questions before we begin? All right, so I'm going to add a new project and call it interfaces. Okay, just to speed up on work, I'm going to be copy pasting code from somewhere earlier. So let's assume I have an interface called IDB functions. While creating an interface, by convention, you precede it with the letter I. So all your interfaces generally begin with the letter I. And while writing the methods in your interface, you would not specify an access specifier. So you won't be saying something like public void insert. Okay, you won't be doing this. Because all methods in the interface are implicitly public. Implicitly public. So by default, they are public. So you cannot give an access specifier. Secondly, what would you be giving in here would be only the signature. You would not be giving in the code body. Are we clear on this? All right. So let's assume I'm using the same interface that I took in the example some time back. Now, if you wanted to create a class that implements that interface, public class, let's say class 1, right? The symbol again is the same, colon and the interface name. So just look at this. When you say you can actually see all those interfaces. All of those are, if you look at the symbol, keep noticing the symbols. I've been telling you from day one. Look at the symbol. By looking at the symbol, you know what it is. I'm using this IDB functions interface. Immediately it gives you an error saying that you have not implemented those methods. So class 1 does not implement insert, does not implement update, and does not implement delete. Just like we did for an abstract class. Instead of writing down the code for this, what are we going to do here? Visual Studio will generate the code for you. All right. So see what I'm doing next. Move your mouse pointer on this and come down to show potential fixes, or you can just click on the down arrow here. And there are two options shown to you. The first option is implement the interface, or the second option is implement all members explicitly. So this is the second way of doing this. So for now, I'm going to pick up the first option, implement interface. I'm going to pick up the first option. In a later example, right now, today itself, but in a later example, we will see the second option there, which is implement all members explicitly. So for now, we'll pick up the first one. What is it going to do for you? What is it adding for you? Look at the code it's adding. It's going to do a public void insert, update, and delete. It's going to add that code for you. So let's add that. On doing so, the error goes away, and you need to put in the code for this one. Let me copy paste the code for this one, so I don't have to write down the code out here. Okay, I'm not gone. Update. So let me do update also. All right. I've also written one more method here, which is display. The method display is not part of the interface, but it's a method that I've written in the class itself. So the three methods that I had were insert, update, and delete. All right. Display, of course, is an additional method that is not part of the interface. Right. Let's try calling the code for this. Calling the code is very simple. All that we'll do here is what? Go and call that method. Insert dot, object dot insert, object dot update, or object dot delete. So give me the code for that. What will I do here? Create an object of type class 1. Right. And what methods would be available to me from class 1? What are the methods that will be available to me? Yes. What all methods would be available to me from object of type class 1 or reference of type class 1? Yes.
Insert,
All methods. All the methods.
All methods. Insert, update, delete, and display as well. Right. In addition to that, also the methods from the object class. So remember, your class is inheriting from object and implementing IDB functions. So if you check this out, O dot, you get all possible methods. You get display, you get insert, update, delete, and you get the object class methods. And then you can, of course, go and call code from here. So you can call O dot display, not an interface method, and you can call O dot insert, which is the interface method. Let's try running this and see what happens. So you get display called as well as insert. So no issues there. Now, if you wanted to call a method on the interface, right, this is the easiest way of doing this. This is the shortest way of doing it. This is the most frequently used way of doing this, to call a method on the interface. But I'm going to show you other ways of doing the same thing. So look at method 2. Look at method 2. And what I'm doing out here is declaring a reference of the interface type. So IDB functions, OIDB, and making OIDB point to O. And what is O pointing to actually? O is pointing to new class 1, and OIDB is now pointing to O. Right? Now to call the methods, I can try calling it from OIDB dot, and which methods are available to me out here? Are all methods available to me? Do I get all the methods out here?
Yes.
Yes.
Yes, sir. So only from the interface,
No,
not the
sir.
display one.
Correct.
Dis-
So if you notice
Display.
closely, the interface methods are available to you, but that display method is not available to you. So why is display not available? Because display is not part of the interface. Display is part of the of the class, and it's available through a reference of class 1, but will not be available through the interface. The interface itself inherits from object. So your other object methods are available out there, but that display method is not available to you. Are we clear on this, everybody?
Yes, sir.
Yes. So this is how I could call the method. So I could call it in this manner also, method 1 or method 2. Which would you prefer? Would you prefer method 1 or method 2?
2.
1.
Why 2?
So as you said it, like using interface, we can write polymorphic code. So I think that for that part.
No, but in this example, if you want to just call insert, if you just want to call insert in this example, would you prefer doing it with 1 or 2? Just to call insert. You like to eat like this? My
No,
hand
sir.
is getting cut off out there, but
Why not?
my hand was there. Is it there? Is it? You like to eat like that?
No.
The direct way would be the better way. No?
Yes, sir.
So the first way is definitely the easier and the simpler and the shorter, lesser code, better way of doing it. The second way is available, but in this example, the first way is better. So then why look at method 2? Because there will be situations where method 1 is not available to you. And the only option available to you is method 2. Also, if you want to use late bound code, he actually gave the right answer. I cut him off and I tried to crack a joke, but if you wanted to use late bound code, then polymorphic late bound code, then the interface would be the second method would be a better way in that case. So there will be situations where 1 is the better option, but there will be certain specific situations where 2 is the only option or is the option that you will need to use. So let's look at method 3 now. And method 3 is just the variation of method 2. So what I'm going to do here is I'm going to say O. I'm going to typecast this to IDB functions. O, I'm going to typecast to IDB functions. And if you now look at this, what do you get out here? What methods do you get out here? We are only getting what? Methods from, ignore the object class methods. That's going to be there common in any case. But other than that, what methods are we getting? We're not getting display. We are only getting what? Insert, update, delete. So you're getting the methods of the interface. So here you're creating an explicit reference. Here you're creating an implicit reference and working with this. So this is another way of doing this. In method 2 and method 3, what are the difference? In method 2 and method 3, what are the difference? Yes. What are the basic difference between method 2 and 3? What did I need to do in 2 that I didn't need to do in 3?
Reference of interface.
Correct. I needed to create an explicit reference here, which I don't need in here. Are we clear on this? So I can directly call it in this manner. So that's method 3. And method 4, of course, is a variation of 3. So see what I'm doing. I'm saying O as IDB function. So there's an as statement here or as operator here which typecast this to IDB functions. So O as IDB functions is an alternate way of writing this. Right? And then if you did dot, what are you again getting here? Only the interface methods. Are we clear on this? Even though you're using the entire object O, you're typecasting this and you're saying that pick up only the interface method. Are we clear on this? How this works?
Yes, sir. Sir?
Yes.
So some few minutes back, you said that interface inherits object class.
Yes.
I didn't get that statement.
Everything inherits from object. Blanket statement. Everything gets from object. Interface, I don't know, 15 minutes back, I said is like what? What is the interface like?
Abstract class.
Like an abstract class with
All abstract.
All
method.
abstract
all
methods.
abstract methods. So internally it's treated like a class only. Another, I have not spoken that as yet with you. I have not done that as yet. I will. There's one more topic that I want to cover with you all where it will be clearer what I'm trying to talk about. But for now, let me just say that it's like an abstract class. Internally, it is like an abstract class. So it will also inherit from object.
So does then interface have a constructor? Have a constructor?
No, like, but not exactly the same as. It's implemented differently. They have implemented it differently for a reason, so that you can, implement more than one interface, get in the method signatures. So even though it's similar, there are a lot of differences out there. What can it only contain? Abstract methods. Okay.
Yes, sir.
All these methods are all abstract methods. They're all, having only the signatures, not really having any code body in there. All right. So I've just shown you 4 different ways of calling that interface method. And I also said that method 1 would probably be the one that you'll use most frequently. But you would be forced to use method 2, 3, 4 in certain situations. 2 is similar to 3 and 3 is, and rather I'll put it this way. 3 is similar to 2 and 4 is similar to 3. Clear? Done? All right. Okay, I'm going to make a few changes here in my code. And I'm going to have a class implement more than one interface. So I've created another interface called file functions. And these are typically operations that you do with a file. So for example, you might want to open a file. You might want to close a file. And you might even want to delete a file. Okay, so these are things that you do out here with a file. All right. The class now is implementing IDB functions as well as ifile functions. So class can implement more than one interface. Can inherit from only one class, but can implement more than one interface. Why is the error shown up? Why is it show you an error immediately here?
We have not implemented.
That
method.
We have not implemented. So let's go and implement it. So to implement it, one of the options here is implement the interface. So what are the methods that I have here? Open, close, and delete. And let's go and implement it. Now, when you implement it, right? When you implement it, see what methods it has added out here. What has it added?
Open and close.
Now, why has it not added delete?
Because it's already implemented.
Implemented from previous interface.
Correct. Because there already was a delete having the same signature. So you can't have two functions having the same name and same signature in the class. Right? If the signature was different, then yes, it would have gotten that method. But it has only gotten a open and a close. Let me just put in quickly the messages here. I have file dot open, and this was I file dot close. Now let's try and understand what this is implying, what this code is implying right now. So what this code is currently implying is that there is only one method for delete. There is only one method for delete. And the code that you have written in delete will be called either when you try to delete something from the database, then also it will call the same code. And even if you delete a file, even then it will call the same code. This is what your current situation means. Now my question to you is this okay with you?
No, sir.
No, sir.
Why is it not okay? Why is it not okay?
Implementation of
Go ahead.
database connection code written in delete implementation.
Correct.
And implementation code required separate.
Correct, because the code that you will write for deleting something from the database and the code that you will write from deleting something from the file will be entirely different. So you can't say that, okay, there's only one code and both will call the same code. So we need two copies of delete. We need two copies of delete. Right? Why has this problem come up? This problem has come up because you've got two interfaces, both having the same method name and the same parameters. If the method name was different or the parameters were different, then it would not cause a problem for you. Agree? If either the method name or the parameters were different, then there would be no problem for you. But because they are the same, therefore you're in a problem area. So how do you resolve this? Now in such a situation, instead of doing it this way, instead of having code written in this way, see what I'm doing. I'm going to say implement all members explicitly. Implement all members explicitly. So this is the second way of implementing our interface. Now when you implement that explicitly, see what code it generates. See what code it generates. Right? So what is the code that is generated here? How is it writing the function now? It's saying void interface name dot method.
Method name.
Right? And now I can have two copies of delete. One copy of delete is here and the other copy of delete is here. So if I have to write down code for this now, I can write down code in this manner. Are we clear on this? I could actually go and write code like this. Let's try calling open and let's try calling close. Let's try calling open and let's try calling close. So we'll go back to our code. And if I did O dot, you'll find that open and close are not shown to you. Open and close are not shown to you. And other methods, insert, update, delete are there. But that second delete is also not there. So my first question to you is, why are open and close not shown? But insert, update, delete are shown. Why are they not shown? Look at the code generated and tell me, why are they not shown?
They are not interface specific.
Look at the code. The code is screaming out at you.
They
Look
are
at
not
line 96,
implemented.
look at line 101.
Access modifier.
Correct. Because they're not public anymore.
Yes, sir. Yes, sir.
And what is available through an object of the class? Only the public methods.
Publics.
So let us change this, and instead of keeping it this way, we will make this public.
Public.
We make this public. Now, when I make this public, it gives me an error. It's saying that you cannot make it public. So if you got a syntax like this, wherein you're saying interface method dot method name, these are implicitly private. You can't go and change the access specifier. So now you've got 2 copies of the method, but you can't call it this way. Are we getting this, everybody? So I will not be allowed to call delete or open or close directly. So I can't call it with method 1. But I also have method 2, method 3, and method 4. So let's try calling it with method 2. How will you call it with method 2? Declare a reference of type interface. Right? Make it point to the object that you have created. Class 1 or the reference of type class 1. Make it point to that. So sorry, I missed out the equal to. And then finally do what? Yes, OI file dot. And what does this show you now? All the interface methods. So you now get to get your open, close, and delete. So let me call delete. I have not written code for open and close. Let me call delete. Are we clear on this, everybody? So this is how I could actually go ahead and call this. And let's try running this. So ifile.delete is the one that's being called out. Could I also call the other delete? O.delete. Right? Could I also call this? This is known as what? This is the idb.delete. Clear? Could I have used method 3, method 4? Method 3 also would have worked. Agree?
Yes.
Or method 4 for that matter. Right? So that's another way of calling it. But method 1, of course, is not available to you. All right. Now, if you come back to the code out here, did open and close cause you problems? Was there a problem with open and close? Yes or no? I'm asking. Open and close didn't cause you any problems, right?
No, no, no.
So what I'm going to do here is open and close. I'll keep it to the way it was earlier. What does this allow me? What does this allow me? Open and close. Direct waves available now here with this. I don't have to go through method 2, 3, or 4. So if it's not causing an ambiguity, no problem. And here, this delete now, instead of keeping it as public, I will change this to what? Yes, idb functions dot delete. So I'm removed the public aspect of this. Why am I removing public? Because I don't want it to be ambiguous. If it delete is it? Is it ifile.delete or is it idb.delete? I'm not sure which one is it. So I'm removing the ambiguity. I'm saying it is not available directly in any case. So insert, update, open, close are available directly, but delete is available through the explicit implementation of an interface. And you can mix and match this. It doesn't have to be all one way or all the other way. So pick it up as convenient to you. Right? This one work. How do I call the other one? How do I call the delete for that one? Yes. I'll use method 4 here, short away. and dot delete. So we could do it, and all the other functions can be called with method. Same way now. Just running the same code, idb.delete and ifile. Are we clear on this, everybody? So you can play around with this. You can mix and match methods that are causing you problems because of same method in two different interfaces. Keep them as explicit implementation, and the other methods keep them as regular methods. Explicit implementation requires what? No access specifier, and then you would specify interface name dot method. Clear? Questions, if any? All right. Now I have I've copy pasted from a ready example that I have. Let me take you through what I've done. Explain to me first what am I got out here? I got a IDB functions, the same as before. What is this one here? Public class one. What is this? What is this doing? Class one also is implementing IDB functions, right? And somewhere later, I also have what? Class 2 implementing IDB functions. So I got different code in here. Okay. Now, if you come back to main, I could create an object of type class 1, and I could create an object of type class 2. Now, how do I call this method with, let's say method 2 if I had to use? I create a reference of type interface and make it point to obj1. obj1 is what? Is an object of this class, class 1. And I could call insert. Similarly, make it point to obj2 and call insert. So what is this insert going to call? What is line 137? What is it going to call? Which one is it going to call? Which insert is this going to call?
So insert of IDB interface, IDB functions.
IDB
Interface.
function.
But now there are two classes. So which class is it going to call this for?
Class 1.
One.
Class 1. And what about this one? What is this line going to call?
Class 2.
Class 2.
Class 2, because it's pointing to class 2. Now look at the line number 137 and 140. Is there any difference in your code on 137 and 140? Are these two lines similar, or are they the same, or are they different? Exactly the same.
Yes.
But in one case, it will go and call the insert for class 1. In the second case, it will call the insert for class 2. So what is this an example of?
Polymorphism.
Polymorphism. So you have polymorphic code that is being now brought with your interfaces. So if you have different classes all implementing the same interfaces, the code that you're writing will start looking the same. And when you're going to write similar code, it's easy to write and maintain code. The moment your code becomes different, then it becomes difficult to you. But if you're going to just repeat the same code multiple times, then it's easy to refer to the code. Right? Have a look at this code. This is just a variation of what I've done. What does this function take as a parameter? What does it take as a parameter?
A reference of IDB function.
Reference of type IDB functions. And I'm calling oidb.insert. Now, what can you pass to this? What can this receive?
An object.
It can receive an object of any class that implements IDB functions. Are we clear on this? This can receive an object of any class that implements IDB functions. So if you look at this, I'm calling, I'm creating two different objects, O1 and O2 of type class 1 and class 2, and I'm calling that method. So this again, is tending towards pattern-based programming. I'm not going to introduce patterns to you, but you would have seen certain patterns when you're working with Java, right? So this is the beginning of trying to write code which is using certain design patterns, and I'm not going to get into design patterns. That's a separate topic by itself for later. We're not doing design patterns now. All right. So this is what you could actually be doing with interfaces. So this third example is just showing you how interfaces could be used. Right. So let's recap some of the things that we said earlier. We started off our discussion with this advantages of interfaces. It's a contract. The class must implement all the interface methods. You're forced to do that. You get similar code in the entire project for all developers. So generally in large projects, you would be using interfaces. You get polymorphic code, and also, interfaces are used frequently in design patterns. So these are the sort of areas where you would need to use this. Okay. One to do for you to do at the end of this, try inheritance in interfaces. So what I wanted to do is create one interface. Let's say it has two methods, A and B. Create another interface that inherits from that interface and add C and D. So the derived interface will now have what methods? AB from the base interface and CD from the derived. So this is something for you to try out in the lab. Are we clear on this, everybody?
Yes, sir.
All right. Now I am not done with interfaces, right? But I am almost done from a time perspective. So I will continue with interfaces first thing tomorrow morning. Right? I'll need a little bit more time to cover one more very important concept in interfaces. So we'll look at that later. But I would also be using, I need 5 minutes more. What do you think is coming up next?
Assignment. Assignments.
Yeah. Don't call it an assignment. Don't call it an assignment.
Homework.
It's no, not homework also. It's my love for you. Right? So I'm going to be sharing something which is just like a present from me to you at the end of every session. I mean, every day I'd like to give you a small little present. Yeah, gift. Just love for you being so good, and good attendance, good responses. Okay, not talking in Hindi, not talking in Marathi, right? All the good things that you all do. Okay. Yeah, so just give me a minute while I open that assignment. I'll be sharing that assignment with you all in any case. Any guesses what the assignment is on? Yeah. Any guesses what it's on? What's based on?
Inheritance.
Inheritance.
No prizes for guessing. So I'll be sharing this file with you in a minute, but if you could just read what's there on the file, and then I will be discussing this. So just take a minute to read what's there on the file. All right. So to begin with, this is the same class that you were working with yesterday, right? Yesterday, I had given you all 2 assignments to work on, 2 separate things. So it's the same class, but now we are adding more classes to this. Now, don't change yesterday's code. You can copy your code and create a new project and paste it in the new project and work on the new project. So don't make changes to your existing code. So if I want, I should be able to see assignment 1 separately, assignment 2 separately, assignment 3 separately. So to begin with, let's start with the employee class. Similar to what you did yesterday, string name, no blanks. Employee number is read-only and auto-generated, same as yesterday. Department number is greater than 0, but one modification out here. What is the modification out here? Yes.
Basic method and abstract.
Basic.
Yeah. So the basic property is an abstract property. Now I have not shown you how to create an abstract property. I showed you how to create an abstract method, right? So you have to figure out on your own how to create an abstract property. Not ask your friend, you have to figure it out on your own. Different, even if you Google it 1 minute, it will take you to get the answer, right? So I'm asking you to create an abstract property. What is the property actually? It consists of what? Property consists of 2 methods, get and set. So actually a property is also methods only. So that's why you can create an abstract property. Secondly, what else have I made abstract here?
Method.
That method calculate net salary or get net salary, whatever the method number, that also is abstract. Now, what is implied here but is not said is that what is implied here without being said? It's got an abstract method and an abstract property. What is also implied is what?
Abstract class.
That the employee should be an abstract class. Because remember, an abstract class only can, or I'll put it this way, the abstract method can exist in an abstract class only. So that's the first class. Secondly, then what am I doing now? This rest of the part is easy. All that we are doing here is what? Manager inherits from employee, adds 1 more property. General manager inherits from manager and adds 1 more property. CEO inherits not from these 2, but inherits from employee. And what am I also asking you to do?
Sealed method.
Make it a sealed method. Now, the note at the bottom is also important. Please read the note out there. Can someone explain to me what this first line means? What do you understand by the first line?
The parameterized constructor in each class should follow the parameterized class constructor.
Correct. So first thing is, if you look at employee class, how many properties are there in the employee class?
4.
4 properties. Now, out of the 4 properties, 1 of them is read-only and auto-generated. So that property doesn't have to be accepted. Agree? So you actually got 3 properties that you'll need in the constructor. So the employee constructor should take either 3 parameters or 2 or 1 or 0 parameters. One possibility is you write multiple constructors. What is the other possibility?
Default parameter.
Default.
So what would you prefer?
Default.
Default.
All right. Now look at manager. Manager has how many properties?
1 of and
It gets 4 from employee
and 1 of
and
itself.
1 of its own. So total of 5 properties. Now out of the 5 properties, of course, 1 of them is auto-generated and read-only. So we don't need that. So manager actually will need a constructor which takes 4 parameters and it will not initialize all 4 values in there. What will it do? 3 of the parameters it will pass to its base class. Understood this? So what we saw earlier in the day, what did we talk about? Constructors in the hierarchy. The derived class constructor will pass the base class values to the base class constructor, and it will only initialize the members of the derived class. What about general manager? How many properties does general manager have? Think and answer. Total number of properties of general manager.
6 properties.
6. Out of which 1 is read-only auto-general. So general manager will have a constructor which takes 5 properties. And of the 5, it will pass 4 to its base class. What is its base class?
Employee
Is manager. Manager will receive 4 and pass 3 to employee. So that's what I mean, that overloaded constructors in all classes calling their base class constructors. Are we clear on this?
Yes, sir.
All right. Secondly, look at the second line out here. All classes to override the abstract members defined in the employee class. All of them, all classes. So manager, general manager, and CEO. When you override them, the basic property will have different validation in different classes. So for example, manager, let's say, I'm just giving an example. Okay, it's not necessarily you do the same thing. Manager, let's say the basic should be between 10,000 and 50,000. General manager, let's say it should be between, let's say 30,000 and 80,000. Right? CEO, let's say it should be between 1 lakh and 2 lakh. I'm just giving random examples. You take your own numbers. So each of them will have different validation code in for basic property. Not just that, I have not mentioned that here, but the calculate net salary method also will be different in all classes, different calculations in different classes. So this is what is required for you. Are we clear on this, everybody? This is what you have to do in the assignment. Any questions, any doubts about any of this? Or will you all go and ask your friend, काय करायचं? काय सरांनी, अहो ते सरांनी काय कोड दिला होता, काय करायचं काय? You're going to say that? Hopefully you will do it on your own. Again, as usual, you will first do what? First priority is completing what?
Classwork.
The examples tried in class. That's the first priority, and then start off with your assignment. You have to master everything that we're done in class. You should be knowing everything about that the next day. If you don't do the assignment, I'm okay with it. I'm not saying don't do it. I'm just saying that priority is completing, knowing the things, and then you can complete that. But do complete it. It's in your own interest. All right. Okay. You have a test coming up. Nisha reminded me that we have a test coming up on Monday, right? So don't be surprised if there's a test. There's a mid-module test covering everything that we have covered up to Saturday, whatever topics that we have covered. So be prepared with the test also. Don't wait till Sunday to do that. Start now only. Every day, prepare for the test. Assume there is a test tomorrow. So then every day you have to learn only a little bit more. Right? Okay. So I am disconnecting from now and I will see you all in the lab. Happy coding.
Thank you.
Thank you.
Thank you so much.
Thank you, sir.
Thank you, sir.